So we know that a female's eggs develop in her ovaries, and that as they sort of develop, we get these fluctuations in female sex hormones released from the ovaries. So to be more specific, we get estrogen, we get progesterone, and we get inhibin released from the ovaries while the eggs are developing. So that's all fine and good, but why exactly is this happening? What exactly are these hormones doing in the female body, and why do their levels change? Well, there's this handy graph that we'll just refer to as the ovarian cycle graph that I guarantee you'll see if you're studying female reproductive physiology. It's actually really quite helpful in understanding and visualizing what exactly is going on in the body during each reproductive cycle. So this is sort of the skeleton of the graph here, just the axes. And I'll orient you to the axes first, and then we'll look at what information the graph actually contains. So the x-axis here is time, and time in this situation is sort of constricted to 28 days because that's how long each reproductive cycle is. And by the way, it says 28/0 here because the 28th day is the same day as the 0th day, if that makes sense. In other words, once you reach day 28 of one cycle, you're on day 0 of the next cycle. There's no sort of gap in between. And remember, ovulation happens here at day 14. So that's the x-axis. And before we talk about the y-axis, I'll just quickly mention that we're going to split the reproductive cycle into two main phases, the follicular phase and the luteal phase. And you'll see why they're called that soon. So on the y-axis, there's a few different things that we'll sort of track at the same time. And the reason they're all here on the y-axis at the same time is because they're all related. They happen at the same time in the body, so we want to see them all at once on one graph. They're even listed in a sort of order on this graph. So first at the top, we've got the gonadotrophic hormone levels, FSH and LH. And remember, these are released from the anterior pituitary gland in the brain. And these hormones affect the development of follicles in the ovarian cycle. And these hormones affect the development of follicles in the ovarian cycle. And we'll actually look at the ovarian cycle just below here. And as the follicles develop, they cause the release of hormones from the ovaries. So the hormone levels are here below. And last, we have stages of the uterine cycle, which are influenced by the levels of sex hormones released from the ovaries. And broadly, the stages of the uterine cycle are menses, or menstruation, where the endometrial lining is shed, the proliferative phase, where a new layer of endometrium forms and grows, or proliferates, and the last phase is the secretory phase, where the endometrium becomes ready for implantation by a fertilized egg. So even if there's no fertilization of the egg, the endometrium still gets ready just in case. And we'll talk about these phases a little bit more later on. And let me just quickly say that in pink up here, in the ovarian hormone levels, the pink here is estrogen, the blue line underneath it is inhibin, and the orangey line is progesterone. So those are the three ovarian hormones that we're going to be concerned with. So we've got this sort of logical stepwise setup here, and hopefully that makes it easier to remember what's going on. So for now, we'll just look at the first half of the graph, the follicular phase part of the graph, and we won't really worry about the luteal phase part of the graph just yet. We'll just get rid of that. So on day 0 here, the anterior pituitary gland is releasing some FSH and some LH, and you can see those baseline levels here. And we know that the FSH is stimulating growth of the follicle here, and you can see it growing as the days go by. And while it grows, its number of granulosa cells is increasing, right? The granulosa cells are represented by this purple color here. And we know that granulosa cells secrete estrogen. So the amount of estrogen in the blood is going up and up and up as these follicles grow. And to add to that, besides what FSH is doing, luteinizing hormone is making the thecal cells that surround the follicle produce a hormone called androstenedione. Androstenedione is really, really similar in structure to estrogen, and actually the granulosa cells get a hold of that androstenedione and convert it to actual estrogen. So the estrogen levels are just going way up, and you can see that reflected here. So as the follicles grow, the estrogen level is just going way up. And by the way, If we look down here at what's happening in the endometrium of the uterus, that's the inner lining of the uterus, we can see that we're in the proliferative phase. And it's called the proliferative phase because the increasing estrogen levels that we see here are inducing a new layer of endometrium to form, since the old one was shed in menstruation in the previous week. So that's what this proliferation phase is all about. So at this point, some really interesting stuff starts to happen. So when the hypothalamus and the anterior pituitary gland in the brain start to sense that the levels of estrogen are super high like this, they begin to release less FSH and LH. And you can see them dipping here. And that sort of makes sense, right? Because the point of releasing FSH and LH in the first place was to cause development of the follicles. And the follicles make the estrogen. So when the brain senses lots of estrogen, it must mean that the follicles are developing, right? So it doesn't actually have to continue to release so much FSH and LH. That makes sense. So that's why we see these dips here in FSH and LH levels in the blood, because the high estrogen levels tell the brain to sort of reduce their production and release of these gonadotrophic hormones. But then it starts to get even more interesting. Our granulosa cells are just cranking out estrogen at this point, and they actually start to produce two more hormones in higher amounts. They start to produce a bit of progesterone, and they start to produce a hormone called inhibin. And let me just say that there's two types of inhibin, inhibin A and inhibin B, but we're just going to consider them as one thing for now, inhibin. And inhibin's role is to inhibit FSH release from the anterior pituitary. So you can kind of see here that as inhibin starts to increase, FSH in blue here starts to decrease. And again, that's because inhibin is stopping the anterior pituitary from releasing FSH. You might think that's the end of the interesting stuff. It gets even more interesting. Do you remember how we said that as estrogen gets higher and higher, it stops the hypothalamus and the anterior pituitary from making more FSH and LH by a bit of negative feedback? Well, it turns out that if estrogen reaches a super high level, like up here, we'll say it reaches that super high level up here, it actually causes the brain to want to release more FSH and LH. It's sort of a paradoxical sounding event. So we reach such a high level of estrogen that the brain tries to release this really, really high amount of FSH and LH. But on the graph here, we only really see a high release of LH and not FSH. So why is that? Aha! Remember earlier we said that our granulosa cells were releasing inhibin, which reduces FSH release from the anterior pituitary? Well, look here. Our inhibin amount is pretty high now, and that inhibin sort of curtails the amount of FSH released from the anterior pituitary, but it doesn't really affect the LH that gets released. So the net effect is a huge release of LH from the anterior pituitary in an event called the luteal surge. And this LH that gets released, plus the still reasonably high amount of FSH that gets released, that sort of pushes development of the follicle to its final step, ovulation. And the egg you can see sort of popping out of the follicle here in the process of ovulation. And remember that happens at day 14 here. So that's the follicular phase and ovulation on the graph.